Okay, so welcome members. In this lesson today we are going to see how do we use more of the Planck-Tangent properties to answer such questions, but please don't forget to subscribe to the channel. Okay, I'm going to go through this question, but please follow, you can pause the video and first write down the question. The diagram below shows a circle with the center O and radius 10.5 centimeters. Two tangents PR and PS are drawn from a point P outside the circle as shown below. Calculate the length of the tangents, the area bounded by the arc, and then the two tangents, getting pi as that. So now, I'm going to sketch this here. Of course, you know that if this is the tangent, it meets or is the radius at 90 degrees. And also now, this one is, let me draw some radius here. It's also going to meet this tangent at 90 degrees. That is the property. And also say that if two tangents are originated from the same point to the circle, then this side is always equal to that side. Now question A, want me to calculate the length of the tangents. Now, if I use this triangle ORP, now I'm going to treat it like this. If I extract out this diagram here using T. If I treat it now, I'm going to do it like this. So I'm going to have this as the longest side there. So start this one now is the 90, and this is our R, then this is our O, then this is our A. Now let's start this angle. Here is 60 degrees. I want to get the R. The length of the tangent I want to get there. Okay, so now instead I have this, then this one here is 10.5 centimeters. So I have the angle, I have the adjacent, I want the opposite. So there I say that we are going to use tan. So our tan of an angle is equal to the opposite over the adjacent. So that now my tan 60 degrees is going to be the opposite if you want PR and PR over the adjacent, which is 10.5. And we cross multiply, our PR is going to be 10.5 and we stand 60 degrees if we cross multiply like this. So then there you press it on your calculator. The answer here I'm having is 18.1865 centimeters. I'm giving the answer for decimal places. So if that is my now PR, it means that we say that since these are written from the same point, it means that also now part F, it means that PR is equal to PS. All of them are 18.865 centimeters, because we say tangents originating from the same point to the circle are always equal in length. So now when we come to this one, we want us to get the area bounded by an arc is here, SQR, and the tangents, and these two tangents. What we are going to do, the idea is, we are going to get the area of this big circle, then we subtract the area of this sector here, this sector. But then this sector, we need this angle here, this angle. But orange, this angle is also going to be 60 degrees, like that. So now, orange, this line from a point to the center, it divides that into two. So this one is only 60 degrees. Now, if I come, then I draw out that R. I mean that sector. You see, we are having something like this. So this, the whole of this is now, when you add these two, you get 120 degrees. Then this is 10.5 centimeters, because this radius is the same as this radius. So now, if you have to get the sector of O, R, S, this, the whole of this, O, R, I mean O, R, S. So you know that area of the sector is equal to the angle at the center over 360, then times pi r squared. So it's that our theta from here is 120 degrees. So getting that now, my area of the sector is going to be now times pi, the W pi as then times radius squared, 10.5 the whole squared. And my area here is going to be, you get, here I'm getting 115.5 centimeters squared. So that's the area of the sector. Now I want also to get the area of the whole of this triangle. What I'm going to do, I want that this triangle, it has the same area as this triangle. So I'm going to get the area of this triangle here. I got this line already, so using ORP, now this is what I have there. So using ORP, I'm going to apply OR, this is right angle to triangle, P. But we got PR, the R was 18.1865 centimeters. Now I can get the area of this one. So area of ORP is going to be, is that this one I'm going to use R half base height. So that R half times the base, which is 10, times the height, which is 18.1865. So that here we are going to get so here we get 95.479 centimeters squared. But you see that now this triangle is going to be having the same area as the triangle OPS. So meaning area of OPS is also going to be the same as area of ORP, equaling to also 95.479 centimeters. Or 791, we are missing 1 centimeter squared. So meaning that now, if we are to get the area, we are going to get the area of this part. This we shall be getting the area of the triangle. So now area of S, area of the whole of this figure here now. The area of this figure R P S, the area of R P S is going to be now this area times this area. So 2 times the area, because we are the same, 95.4791, which is going to give us, when we multiply that, you get so here I'm getting 190.9582 centimeters squared. Now the area of this shaded part, this shaded region, is going to be area of shaded region, or the area bounded by the earth and the two tangents is going to be, we are going to get the area of the whole of this, then minus the area of the sector shall be getting the area of the main thing. So the whole of that one is going to be 190.9582 2, then minus the area of that sector, 5.5. The whole of this will be that centimeter squared. So now our area of the shoulder machine is going to be we are getting 75.4582 centimeters squared. And so that's how we handle that, members. And don't forget to subscribe to the channel. I wish you the best.